Okay, here we go. We're working on worksheet 10.1. Remember, you have some notes describing polynomials on page 23. You'll want to have that handy, especially because this first one's a bit of a doozy. So we have a lot of terms here, a lot of ways to describe polynomials. One way is to describe the degree of the polynomial. So that's the highest exponent you see. Now this is kind of a silly example. We just have a -7 sitting there. It's a constant. So -7 is our constant right now. Hopefully you're kind of thinking. If you look at our definition of constant, it's a term without an x attached to it. But to answer the degree, we're supposed to have a variable with an exponent. Well, we could say that this is getting multiplied by x to the 0. Remember, x to the 0 is the same as 1. And -7 times 1 is just -7. Whenever you see a constant, you could always think this, that it has an x to the 0 multiplied with it, or any variable to the 0 power multiplied with it. So what's the degree of this polynomial? Well, the highest exponent I see is a 0. The degree classification, we don't actually talk about when it's a 0 or when the degree is 0. We'll call it a constant. And the leading coefficient is a -7. Let's try number 3. That one's maybe a little more fun. The highest degree, the highest exponent you see here, and again, you can still use that x to the 0 trick if you want here, but that's a 0. This, or an n to the 0, since they're using the variable n. This degree is 2, and this degree is 3. So our highest exponent, or our highest degree, is 3. And we classify the polynomial off of that highest degree. So this is a cubic polynomial. The leading coefficient is the multiplier on that highest degree variable. So the multiplier there is -10. And the constant is a +5. Here, the highest degree I see, what's the degree on this k? That's a 1. If you don't see an exponent, it's a 1. So the highest degree is 2, which makes it a quadratic. The leading coefficient is a -2. And then what's the constant? Is there a plain old number being added here without a variable? Yeah, we could put a +0 at the end. So the number is 0 there. So here, if the polynomial is not in standard form, rewrite it in standard form. Remember, with the highest degree first. The exponents go in descending order. State the polynomial's degree, degree classification, leading coefficient, and constant. So this is the same thing, except for we need to put it in the standard form first. So keep working on the odds here. So we've got negative, so look for the highest exponent first. It's there, and that's a -4. So we've got -4k to the third, -4k squared, -10k, and +9. This is a +9 out there. So it's in standard form, it's right there. What's the degree of it, or the highest exponent? It's this 3 sitting right there. So what's that make it for a classification? That's a cubic. The leading coefficient is -4. The constant is +9. And then write each term in the polynomial separated by commas. So really we can just copy down either the original polynomial or the one in standard form, but showing that we understand what terms are. There's one term. Here is another term. Here is another term. And finally there's a 9. There's those 4 terms that are being added or subtracted together. Or actually, since I'm using the negatives out in front, they're just being added together. Number 11, standard form. It already is. The exponents are in descending order: 2, 1, 0. So the highest degree is 2, which makes it a quadratic. The leading coefficient is 9, and the constant is a -5. And we have 3 terms, a 9n squared, a positive 8n, and a -5.